Okay, here's your overview for carboxylic acids. Quick reminder then of the number of covalent bonds that we'll find in hydrogen, oxygen and carbon. So hydrogen can form one covalent bond with other atoms, oxygen can form two, and carbons can form up to four. Quick reminder, these we're talking about covalent bonds. Right, once we've got that little reminder, let's have a little look at some of the main features of the carboxylic acids. They've all got a feature in common, so they all belong to something called a homologous series, homo meaning the same. So what have they got that's the same? They have the same functional group, and is carbon, oxygen, oxygen and a hydrogen. This little line here represents the covalent bond. So we call this the functional group. And all it means is that for something to be a carboxylic acid, it has to have COOH as part of its structure. So let's have a look at the first four. We're going to look at 1 carbon, 2 carbons, 3 carbons and 4 carbons. So let's get the naming right. If something has 1 carbon, it's meth, then it's eth or eth or meth or eth, then we've got prop and then bute. So the prefixes, the names always start the same. If it was 5, it would be pent, 6 would be hex, and so on. All these are carboxylic acids, so it's really easy to finish off the word. We just write anoic acid. Pretty easy. So they all end in anoic acid. Let's do the rest, why not? Anoic acid, anoic acid. Now I know I've written a bit of a gap here between these, but we would say methanoic acid, ethanoic acid, propanoic acid, butanoic acid. Alright, so we've got our 1 carbon, 2 carbon, 3 carbon, 4 carbon. Right, let's quickly show you how to draw one of these. Let's pick propanoic acid. There's a lot, from the name, there's a lot we can work out in terms of helping us design the structure. So if it's prop, then it's 3 carbons. So let's get those drawn then. So we've got 1, 2, 3. So we'll start off with our 3 carbons. We need to have the functional group COOH, so let's put that in now, and let's remind ourselves of the number of bonds that these atoms can form. So carbon needs to have 4 and oxygen needs to have 2. So here's how we draw it. We draw one oxygen that has a double bond with the carbon. So remember, oxygen has to have 2 covalent bonds. That carbon has now got 1, 2, 3 already, so it can only make one more. So we've used one oxygen, we've used 1 carbon, we've used 1 oxygen from the functional group. There's the first carbon, there's the oxygen. So I've only got an oxygen and a hydrogen left to fill up the structure. So the way to solve this problem is, if we put the oxygen here, there's 1 bond already for the oxygen, there's the other one, and the hydrogen fits in as well. So let's go back to our checklist. Hydrogen has 1 covalent bond, oxygen has 2, this oxygen has 2, this carbon has 1, 2, 3, 4. So that's the functional group done. So let's just sort of highlight that. So this is our functional group. Alright, this is what makes something a carboxylic acid. Then we can just complete the rest of the structure. So all we've got to do is just add in the hydrogen. So carbon number 2 has already got 1, 2 bonds. Let's put 1, 2 there with a hydrogen and a hydrogen. And this carbon over here has got hydrogen and hydrogen. And we can put 1 more in as well. If we want to write out the structure, not the displayed version, but the chemical structure, the chemical formula, then we write the functional group separately to help us identify that it is a carboxylic acid. Let's put COOH in already. And then we just write whatever's left over. So we've got 2 carbons, so let's put C2. And we've got 1, 2, 3, 4, 5 hydrogens, job done. Okay, so now that's our structure done. We've got the formula written out as well. We also need to know and be aware of some of the properties of carboxylic acids. The first one is that they dissolve in water, and when they do, they form acidic solutions. So we write Sol with a superscript N on that, and it means then that you're going to get a pH less than 7. If you react them with a carbonate, calcium carbonate, lithium carbonate, any one of the carbonates, then you're going to make some CO2, and you can use lime water to test for that. You'll get some fizzing happening, okay, because you get an acid reacting with the carbonate. They do form weak acids, or they're known as weak acids. Oops. Okay, so we get weak acids. And the final thing that you need to be aware of, if you react a carboxylic acid with an alcohol, then one of the products you get is an ester, which comes up in the next lesson. Right, quick overview then. So make sure you're familiar with the number of covalent bonds for hydrogen, oxygen and carbon. That helps you draw the structure out. They've all got the same functional group, they're all part of the same homologous series. The first four are methanoic, ethanoic, propanoic and butanoic. I've done an example of how to draw propanoic. You should probably have a go at trying to draw the other three. We've done the displayed formula first and chemical formula after that. I need to know some of the basic properties of the carboxylic acids too.